This video will demonstrate how to use SPSS to conduct a factorial analysis of variance. The factorial analysis of variance has more than one independent variable and one dependent variable, as compared to ANOVA that analyzed one independent variable with more than two levels. In this case, our independent variables will be father's education revised, which we've been working with, high school grad or less, students with fathers who had some college, and students with fathers who had a BS or more. And then our other independent variable will be math grades. And in this case, math grades are also categorical and defined as less than AB and mostly A or B. And our dependent variable is our math achievement scores, which range for this particular assessment from negative 8.33 to 25. So to analyze this data, these independent variables, we'll go to General Linear Model, Univariate, and we will put math achievement in our dependent variable box, and we'll go down and get father's education revised for the fixed factor box, and math grades for the fixed factor. For plots, to make it more interpretable, I think it's best to put father's education revised on the horizontal axis and have math grades on separate axis, because there's only two categories of math grades. And then we can add and then continue. For post-hoc, we can move father's education over and click on Tukey. I'm not going to move math grades over because math grades only has two levels, mostly A or B or less than A or B. And when there's only two means to compare, SPSS will not conduct the post-hoc test. What you have to do is go up and just simply look at the means. And then under options, I want descriptives, statistics, estimates of effect size, observed power, and homogeneity tests. And then we'll go continue and then OK. So in this case, again, we see our coded levels of father's education and the numbers in each level. But now we also have two levels for these students, less than AB or more, mostly AB. And so we need to make sure that these numbers are correct. This table gives us the means, the math achievement means and the standard deviations for less than AB and mostly AB by each level of father's education for these students. We also see that our Levine's test is significant. So that means that the variances are, or at least one group variance differs from one another, either by math grades or by father's education level. For now, we're going to ignore that. Normally, what we would do is go to Explore, and we'd look at the distributions of some college, BS or more, and high school diploma or less. We'd look at those distributions to see if they're significantly skewed or not. And we'd also look at the distribution of math scores for less than AB or mostly AB, and probably look at the Shapiro-Wilks test to determine if they're significantly skewed. Moving on, we can see that the three lines that we're going to be interested in looking at is the main effect of father's education, which is significant. So at least one of those group means for math achievement differ. We can look at math grades, and that's significant. So math grades differ, mostly AB and less than AB, but now we see that the interaction effect, Father's Education Revised by math grades, is significant. So when the interaction effect is significant, that indicates that we cannot interpret the results or the main effects, because what it's saying is that students' math grades differ at one level of Father's Education but not at another. Or we can say that Father's Education levels differ at one level of math grade but not at the other. We can still interpret the post hoc tests for the main effects, but really we have to wait and look and conduct what we call a simple effects analysis. And I have made a follow-up video that will do that for us. So when looking at this plot, we can see that this green are the math achievement means for students who had or earned mostly A and B in math by differing levels of Father's Education. And this plot, the blue, or I should say this line, the blue, is students who earned less than AB and at each level of Father's Education. So the results indicate that we have a significant interaction. And so what that means is that the means, the math achievement means for less than AB and mostly AB differ at least one level, differ significantly. So this math achievement mean and this math achievement mean at high school for students whose fathers had a high school diploma or less, they don't seem all that much different. We see more difference between students who earn less than an AB or more than mostly ABs in math in terms of math achievement, and we see the largest gap here. So what we can say is that there may not be a significant difference between this set of means, but is there a significant difference between this set and this set? And we can't tell that from the analysis that we've just done. All we know is that the Father's Education levels differ regardless of math grade. Math grades differ regardless of Father's Education level, but then the complicating factor is that we have an interaction effect. And what that means is that we have math achievement means differing between students who earn less than A or B in math and mostly A's and B's in math on mean math achievement. So now what we have to do is a simple effects test to determine where that difference is. Is it at BS or more? Is it at some college? Is it even at this level? But it's likely going to be probably not at this level, but maybe at this level or this level. So that will be the next analysis in the next video that I will demonstrate.